The goal for this exercise is to rationalize the denominator. That is, to remove all the roots from the denominator of this expression. This expression on the left is the expression that I had originally, and our goal is to remove the roots from this expression right here, specifically from the denominator of this expression. The way I do that is that I multiply by a new fraction. This is the new fraction that I'm going to multiply with this fraction that is the one that I had originally. And this new fraction is composed of the conjugate of the denominator. This is the denominator, and the conjugate of the denominator is nothing more than taking the first term and leaving it exactly as it is, as positive x squared, and taking the second term and changing the sign. Here it was minus 27 minus the square root of 27, and here it is plus the square root of 27. So the conjugate of x squared minus 27 is simply x squared plus 27. I changed the sign of the second term. Now I use that same expression both on the denominator and on the numerator. And after I do that, I proceed with the multiplication of the two denominators and the multiplication of the two numerators. Now, just so you know why I can do this, it is because I have the same thing on the numerator and the denominator. Because I have the same thing, this divided by this simply equals 1. So performing this operation is just the same thing as if I was multiplying by 1. That's why this is allowed to be done. Now, the reason I do all of this, as I said in the beginning, is to remove the roots from the denominator. So let's proceed with the multiplication and the removal of this root from the denominator. I am going to multiply now the two denominators, x squared minus 27 multiplied by x squared plus 27. What I'm going to do here is use the FOIL method. And if you remember the FOIL method, I start by multiplying the first term of each one of the two expressions. So the first term here is x squared. The first term here is x squared also. X squared multiplied by x squared is x to the fourth power, x with an exponent equal to 4. Now, the second step in the FOIL method is to multiply the terms that are on the outside. And the terms that are on the outside are x squared and positive square root of 27. So that is this term right here, the terms of the multiplication of the outside. X squared multiplied by positive square root of 27. Now, the next step in the FOIL method is to multiply the interior. The interior terms, the terms that are on the inside, are negative 27 and positive x squared. So the multiplication of negative 27 times x squared, I'm putting it here. Here you can see it. And I'm putting the x on the front. So it is minus x squared multiplied by the square root of 27. And the last step, using the FOIL method, it's the L that stands for last. And the terms that are last are negative 27, negative square root of 27, and positive square root of 27. And that is what I have here, also last in the end. Now, as you can see, all of this expression, I have to simplify it now. Now this term and this term are both equal but with opposite signs. One is positive x squared, square root of 27, and the other one is minus x squared multiplied by the square root of 27. So this minus this one simply equals 0. So those two cancel each other out. They disappear from the expression. Okay? And now I have the square root of 27 multiplied by the square root of 27. And the square root of 27 multiplied by the square root of 27 just equals 27. This operation is the square root of 27 squared. I have explained it in previous examples why that happens. If I have the square root of any number multiplied again by the square root of that number, the result is simply that number. The steps that you can see for that explanation, well, you can follow them here. Multiply x with an exponent 0.5 that equals that is the same thing as the square root. The square root is nothing more than an exponent equal to 1/2 or 0.5. In this case, I have to add those exponents. So 0.5 plus 0.5 is just x with an exponent 1, and x raised to the power of 1 or x with an exponent 1 simply equals x. So this is the whole explanation of why the multiplication of two square roots with the same radicand, the same number or variable inside of the radical sign, simply equals what is on the radical sign. So all that multiplication that we had before, which was the multiplication of all of this, all of that simplifies to just x to the fourth power minus 27. Okay? Multiplication of this term, of this expression, times this expression equals x to the fourth power minus 27. So that is what we have now here in the denominator. Okay? All of this became x to the fourth power minus 27, and all of this multiplied by 1 is just the same thing, x squared plus the square root of 27. So now let's see if there is something else that I can simplify here. What I'm doing now is taking the 27 and factoring it. The factorization of 27 becomes 9 multiplied by 3. 9 times 3 is 27. So 9 times 3 is 3 squared times 3. 3 squared is 3 times 3 is 9, and the other 3 stays the same. Now I have a number with an exponent equal to 2 inside of a square root, and the square root is a root of grade 2. So whenever I have a square root, or what is the same thing as a root of grade 2, and I have on the radicand on the inside a number or a variable with an exponent 2, I can take that number outside of the radical sign. So that is what I did here. The 3 with an exponent 2 goes to the outside of the square root, and the 3 that does not have an exponent equal to 2, well, it has to stay on the inside of the square root. And after that, there is not much simplification that I can do. Okay? So, at the end of the day, what we have is that 1 divided by x squared minus the square root of 27 equals x squared plus 3 multiplied by the square root of 3 divided by x to the fourth power minus 27. I know it does not look more simple. It does not look like we did any simplification. But simplification was not the goal of this exercise. The main goal here was to remove all of the square roots from the denominator, and that we did.